Welcome to The Explainer. So the AI revolution is obviously here. We're seeing all this incredible stuff, from text that writes itself to videos that are just mind-blowing. But behind all that digital magic, there's a very real, very physical problem that's growing like crazy, and it all really boils down to one question.
So what is powering this whole thing? It sounds like a simple question, right? But the answer is getting incredibly complicated. It's not just about having a powerful computer and plugging it into the wall anymore. The sheer scale of what we're now asking AI to do, well, it's creating a challenge that goes right to the heart of our entire industrial infrastructure. And just to give you a sense of that scale, get this. Generating a video with AI can take 10,000 times more computing power than just a simple text prompt. Just let that sink in for a second. 10,000 times. We've basically gone from asking for a sentence to asking for an entire movie, and the energy that takes has just exploded in a way almost nobody saw coming. And that leads us right into our first major problem, the AI power crunch. This absolutely massive jump in computing power is creating a demand for electricity that data centers have never seen before, and it's shaking up the entire energy world.
It makes sense, right? The more capable AI gets, the more we want to use it. First, it was just text, then came images. Now it's all about video. And every single one of those steps up in complexity is a huge leap in power consumption. And this isn't some problem for the future. It's happening right now. And it's got tech companies in a flat-out desperate race for electricity.
Okay, so why not just build more power plants? That's a great question, and it leads us straight to the real villain of our story, the Great Grid Bottleneck. See, the problem isn't just making the power, it's our ancient system for moving it around.
And here's where the economics get kinda weird. The cost to actually generate electricity from stuff like solar or natural gas, that stayed pretty flat, or in some cases, it's even gone down. The real problem, the part that's getting more and more expensive, is the cost of moving that power through the grid's transmission lines to get it where it needs to go.
And this all leads to a massive traffic jam that has a name. The interconnect queue. It's basically the official waiting list to plug a big new project like a power-hungry AI data center into the main grid. You can't just show up and plug in. You got to get in line. And that line, well, it's getting insanely long.
And I mean it is getting dramatically longer. Just a few years back, the wait was around 2 years. Today, you could be waiting 5, 6, even 7 years to get power. In the AI arms race, where speed is literally everything, waiting 7 years for electricity is an eternity. It's not an option.
So what's the holdup? Well, it's a perfect storm, really. You've got layers and layers of state and federal laws, you've got environmental reviews, local permitting issues, and on top of all that bureaucracy, there are real-world physical problems, like shortages of critical gear like transformers, and the simple fact that a lot of our grid infrastructure is just plain old. It wasn't built for this.
This crazy bottleneck is forcing companies to find a radical new solution. It's creating what you might call a tale of two grids. You've got the old, slow public one, and now a new, much faster power play built for the AI era.
And here's the simple but really powerful idea that's changing everything. If connecting to the grid is way too slow, what if you just didn't? What if you built your very own power plant right next door to your data center? I know, it sounds pretty extreme, but it's quickly becoming the go-to strategy. Now, the industry term for this is behind-the-meter generation. It just means the power is made and used right there on site, sometimes without ever touching the public grid at all. It gets rid of the whole transmission problem, and, this is the most important part, it lets you skip that long, painful wait in the interconnect queue.
And this chart right here, this is why the industry is pivoting so hard and so fast. Why would you wait up to 7 years to connect to the grid when you could build your own power source on site and be up and running in as little as 9 months? For a company in the middle of the AI race, that single choice is the difference between leading the pack and being left in the dust.
But, okay, this new approach brings its own set of technical problems. Modern AI training, with all its power-hungry GPUs, causes the electrical system to, and I'm quoting here, freak out, with 10 to 20 megawatt shifts several times per second. These are huge, sudden power swings that the old grid and even some on-site generators just can't handle. This is where large-scale batteries become the absolute secret sauce that makes this whole thing work. So when the GPUs suddenly demand a massive spike of power, huge on-site batteries can respond in less than a second, delivering a giant burst of electricity. They act as this crucial shock absorber, protecting the generators and the grid from these wild, damaging power swings.
And we can see this exact model playing out in the real world right now. Just look at the Colossus supercomputer project down in Memphis. They managed to get that data center running in an incredible 122 days. How? By using temporary, on-site natural gas generators. But the real secret weapon was a massive installation of battery megapacks to handle those power loads while they worked on fast-tracking the grid connection in the background.
And make no mistake, this is not just a one-off thing. The entire industry is pivoting. According to one survey, the number of data center operators planning to build their own on-site power tripled. It went from 10% to 30% in just 6 months. That is a tectonic shift in strategy, and it's all driven by one thing: the need for speed.
So, this new reality brings us to our final point. The future is deregulated. The future of AI is now completely tangled up with energy policy, and the winners of the AI race, they might not be decided by who has the best tech, but by who's in a location with the friendliest rules for building power.
And right now, we're seeing two totally different models play out. You have a regulated state like Ohio, where the utilities are trying to create new rules for on-site power, but it's complex and it's slow. Then you contrast that with a deregulated state like Texas, where the free market basically gives companies way more freedom to build what they need faster and with fewer hurdles to jump through. And what this means, as one expert put it, is that states with fewer regulatory headaches, states like Texas, are now super primed to win the race for these new AI data centers. Think about that. A state's energy policy has suddenly become one of its biggest competitive advantages for attracting billions of dollars in AI investment. So let's just tie this all together. What have we learned? First, AI's thirst for power is a huge and very sudden new challenge. Second, the old power grid is now a major bottleneck because of time, cost, and red tape. Third, behind-the-meter generation is the fast, new solution everyone's jumping on. Fourth, batteries are the critical tech that makes it all possible. And the big takeaway? The futures of AI and energy are now completely, 100% inseparable. Which leaves us with one final big question. The AI revolution is here, and it promises to completely reshape our 21st century world. But could its biggest roadblock end up being a power grid that was built for the 20th century? The race is on. Thanks for watching.